Today we're going to cover two sections of notes today. In the first section, we'll be learning how to add and subtract polynomials, and in the second one, we'll be multiplying polynomials. Let's start with adding. In order to add polynomials, I want to rewrite each of these expressions in descending order, aligning like terms. And I'm going to use placeholders as needed. So what that means is, if I'm missing a term such as x. In here, I've got 5x to the fourth, and then I've got an x to the third. I've even got an x squared here. But then it goes from x squared to just a plus 2. So I don't have a plus any amount of x or minus any amount of x. So I'm going to use a placeholder there saying I've got 0 of them. And we'll see why in a moment. So let's start by rewriting this in descending order. 5x to the fourth minus x to the third plus 4x squared. And then here I don't have that x term, so I'm going to use a placeholder plus 0x and then plus 2. Directly underneath it, I'm going to write my second expression. So I don't have an x to the third here, and I don't have a constant, so I have to use placeholders for those when I get there. Let's start with 3x to the fourth. And then, as I mentioned, I don't have an x to the third term, so plus 0x to the third. And then plus 6x squared minus x, and then no constant, so plus 0. Then step 2 says add like terms. So put a big plus sign over here. And let's see what we get. So going straight down, I can see 5x to the fourth plus 3x to the fourth is going to make 8x to the fourth. And the reason I used a placeholder here is because now I can see all of my x to the thirds in one nice column, whereas if I didn't use a placeholder, I would have squeezed that x squared over to the left here, and it wouldn't have made sense to have an x to the third here with an x squared below it. So that's one reason. The second reason is it's just a little bit easier for us to see exactly what we're adding or what we're subtracting. So this will be negative 1x to the third plus 0x to the third. So I end up with negative 1x to the third, or just minus x to the third. 4x squared plus 6x squared is going to make 10x squared. 0x plus negative x, so negative x. And then 2 plus 0, so plus 2 at the end here. My answer is 8x to the fourth minus x to the third plus 10x squared minus x plus 2. Let's do another one. So in this one, I've got 10x minus 18x to the third plus 6x to the fourth minus 2. I'm noting that I don't have an x squared term in this first expression. And then over here, I've got negative 7x to the fourth plus 2x to the third. I don't have an x squared term here either, plus x and then plus 5. Now, in the event that you don't have that term that's missing in all of the expressions that you're working with, in that case, you don't have to use placeholders if you don't want to, since you're going to have 0 of them at the end anyway. So let's start with 6x to the fourth minus 18x to the third. As I mentioned, I would normally use a placeholder plus 0x squared here, but since the other expression doesn't have that either, I'm just going to skip it and then do plus 10x minus 2. Okay, underneath this, I'm going to write, starting with my highest power negative 7x to the fourth plus 2x to the third plus x, and then plus 5. All right, we're adding these together. So let's put a big plus sign over here. Okay, 6x to the fourth minus plus negative 7x to the fourth is going to be a negative x to the fourth. Negative 18x to the third plus 2x to the third will give us negative 16x to the third. 10x plus another x will make 11x. And negative 2 plus 5, that's going to be positive 3. So my answer here is negative x to the fourth minus 16x to the third plus 11x plus 3. All right, let's talk about subtraction. Very similar. I'm going to rewrite in descending order. Again, aligning like terms, using placeholders as needed, and then I'll subtract those like terms. But I've got to be really careful with negatives, and I always have to go back to my operation. When I was doing addition, I could kind of just go straight down. Here, I have to remember, don't go straight down, make sure that you're subtracting. So let's start by rewriting. I've got 12x to the third, that's my highest power, so we'll start there. So 12x to the third minus 8x squared plus 5x, and then plus 19. All right, my second expression, I've got negative 18x to the third plus 6x squared minus 9x, and then plus 3. All right, we are subtracting, so big minus sign to the left here. And let's start subtracting. Be careful with negatives, it says, and another note is make sure you're going back to this operation. So 12x to the third minus negative 18x to the third. This is subtracting a negative, so we're really like we're adding. This is going to make 30x to the third. Negative 8x squared minus 6x squared. It's going to make negative 14x squared. 5x minus negative 9x, that'll be 14x. And 19 minus 3, so that's going to be 16. Okay, let's do one more with subtraction. My highest power is x to the fifth. So I've got negative 5x to the fifth. Noting I don't have an x to the fourth, but I don't have an x to the fourth over here either. So I can ignore x to the fourth's placeholder. Then I've got a 3, a 2. I don't have an x term. I do have an x term over here though, so I do need to make that placeholder. So, okay, with that in mind, I can skip over x to the fourth, but I need to make my x term placeholder. So negative 5x to the fifth. Then I can go straight to 8x to the third, so plus 8x to the third. Minus 4x squared. Okay, this is where I said I don't have an x term, but I do over here, so I do have to make a placeholder. So plus 0x. and then plus 19. My second expression, my highest power is x squared, but since I already have x to the fifth all the way down to this x squared, I've got to use placeholders for x to the fifth and x to the third here. So 0 x to the fifth plus 0 x to the third. Now I can start with my plus 2x squared. And then plus 10x plus 9. All right, we are subtracting, so big minus sign to the left. And let's go ahead and subtract. Negative 5x to the fifth minus 0x to the fifth, so this will remain negative 5x to the fifth. 8x to the third minus 0x to the third, that's going to remain 8x to the third. Negative 4x squared minus 2x squared, so this will make negative 6x squared. Again, this is where placeholders are useful because instead of just writing this 10x like I did the negative 5x to the fifth and this 8x to the third, I can't do that because this is really 0x minus 10x. So this is going to make negative 10x. And then I've got 19 minus 9. So that's going to be plus 10. Here's a real-world model of this in action. So I've got example E. The data from the U.S. Census Bureau for 2005-2009 shows the number of male students enrolled in high school in the United States. This can be modeled by the function m of x, m for male, I assume, equals negative 10x to the third plus 74.2x squared minus 3.4x plus 8,320.2, where x is the number of years after 2005, and m of x is the number of male students in thousands. Okay. Next, the number of female students enrolled in high school in the United States can be modeled by the function f of x here for female equals negative 13.8x to the third plus 55.3x squared plus 141x plus 7,880, where x again is the number of years after 2005 and f of x is the number of female students in thousands. We want to find a new equation t of x that models the total, so t for total, the total number of students enrolled in high school in the United States after 2005, and then we're going to use this equation to estimate the total number of students enrolled in high school in the United States in 2009. Okay, so let's start by thinking through if I've got an equation for the number of male students, and I've got an equation for the number of female students, and I want to know the total, assuming this encompasses all the different possibilities. Again, this was written in 2005. So I can take this equation, add it to this equation, and this should give me t of x. So let's start there. Let's write out m of x. This is negative 10x to the third plus 74.2x squared minus 3.4x plus 8,320.2. And then f of x, this is negative 13.8x to the third plus 55.3x squared plus 141x and then plus 7,880. Now, My thought process is if I add these together, big plus sign here, this should give me t of x, which is the total number of students. So let's see what that is. I've got a negative 10 minus, or no, plus negative 13.8. So that's going to be negative 23.8 x to the third. Okay, 74.2 plus 55.3. 74.2 plus 55.3. That's going to give me 129.5. So plus 129.5 x squared. Negative 3.4 plus 141. This is 137.6. So plus 137.6x. And then finally, 8,320. Make sure that says 20.2 plus 7,880. This is 16,200.2. So this is my new equation that's going to model the total number of students. Now, what it's going to ask me to do is estimate the total number of students enrolled in high school in the United States in 2009. So remember that this is for after 2005. So every x value, after this, so 1 would be 2006, 2 would be 2007, say 3 would be 2008, 4 would be 2009. So this is asking for 2009. So I'm going to plug in x equals 4 into this equation that I've got. So let's plug in negative 23.8. And then this will be times 4 to the third power. And then plus 129.5. Then times 4 to the second power. I'm noticing I've got to actually change this negative 22.8 to a 3. There we go. Negative 23.8 times 4 to the third power plus 129.5 times 4 to the second power. Yep. Okay, now we can continue. Plus 137.6. That'll just be times 4. And then plus 16,200.2. So I've got t of 4 equals 17,299.4. But remember that this represents the number of thousands of students. So if I actually take this times another 1,000, then I get, let's see, 17299,400. Commas in place. That'll be 17,299,400 students in total. Okay, so that takes care of adding and subtracting. What about multiplication? So for multiplying polynomials, we're going to do something similar that we've done before. We're going to use a box. So we're going to set up a box and multiply through. So let's just jump to our examples so we can see what that looks like. I've got x plus 2 times 1 minus 4x plus 2x squared. So let's set up a box. So I'm multiplying 2 terms by 3 terms, so I have to set up my box appropriately. And over to the side, I'm going to put x plus 2. And then on top, let's do 1 minus 4x, and then plus 2x squared. Okay, let's do some multiplication. X times 1, this is just going to be x. X times negative 4x, this will be negative 4x squared. X times 2x squared, so this will be 2x to the third power. Okay, down here I've got 2 times 1, so 2. 2 times negative 4x will make negative 8x. And then I've got 2 times 2x squared, so that's going to make 4x squared. Then what I want to do is just write this out in descending order, combining like terms. Now I'm noticing that I've actually got some like terms here, so I'm going to do this x and this negative 8x. I'm just going to shade in these cells. And then I've actually got 2 terms with an x squared, so we're going to shade in negative 4x squared here with a different color, and then this positive 4x squared over here. All right, now in descending order, highest power is x to the third, so this will be 2x to the third. Next highest power is x squared, negative 4x squared, and positive 4x squared. Well, when I combine those, that's going to go to 0x squared, so I'm just not even going to write that. X and negative 8x will be negative 7x. And then I've got a plus 2 here. Okay, next one. 3x minus 4y, so 2 terms, times 2 plus xy minus 7x squared. Okay, so another 2 terms and 3 terms. Let's make a box. Okay, off to the side, let's do 3x minus 4y. And along the top, I'll do 2 plus xy, and then minus 7x squared. All right, 3x times 2, this will be 6x. 3x times xy. So multiply your numbers to numbers, x's to x's, y's to y's. If you don't have something, you're just going to copy it over. So I don't have a number to multiply to. Technically, I get a 1 here. So this will be 3. And then x times this x will make x squared. And I don't have a y here, but I do in this term, so I'll just copy that over. 3x times a negative 7x squared. 3 times negative 7 will make negative 21. And then x times x squared will make x to the third. Negative 4y times 2, so negative 8y. Negative 4y times xy, so negative 4. Copy over this x. And then y times y is y squared. Lastly, negative 4 times negative 7 is going to be positive 28. And then x squared y. Do I have any like terms? Yes, I've got an x squared y here and an x squared y here. So those are actually like terms. I'm just going to shade those. Just so I remember to combine those like terms. All right, starting with the highest power, on x at least, negative 21, x to the third. I'm going to combine these two together, so I've got 3x squared y and 28x squared y. That'll combine to 31x squared y. And then I can go really any order, so I'll do plus 6x here, that's fine, minus 4x y squared, and then minus 8y. So a bit of a long answer, negative 21 x to the third plus 31 x squared y plus 6x minus 4x y squared minus 8y. Okay, a couple more. Here I've got three terms again, x to the third plus x squared y plus y times two terms, x squared minus x. So let's make another box. You could do this the tall way and then do 3 down and then 2 over. I always kind of just prefer doing this the longer way, like so. So I'm going to keep doing that. This is where I'm going to put my two-term expression, x squared minus y, or x squared minus x. And then along the top, I've got my three terms, x to the third plus x squared y plus y. All right, let's see what we get. This will be x squared times x to the third, so x to the fifth power. X squared times x squared y, so plus x to the fourth y. X squared times y, so just copy those over. Negative x times x to the third will make negative x to the fourth. Negative x times x squared y, so negative, and then x to the third y. And lastly, negative x, y. Any like terms here? Doesn't look like it, so I can just go ahead and write all 6 of these out in descending order, starting with my highest power on x, x to the fifth. Then I'll just go plus x to the fourth y minus x to the fourth. Then I've got my x to the third here, so minus x to the third y. Then I'll do my x squared 1 plus x squared y minus xy. All right, one more, then an application. So in this last one, I've actually got 3 terms multiplied to another 3 terms. I've got 4x squared plus 3x plus 2, multiplying that to 3x squared plus 2x minus 1. So I need a bigger box. 3 by 3. Okay, let's do down the side. I'll do this one, 4x squared plus 3x plus 2. along the top, I'll do 3x squared plus 2x, and then minus 1. Okay, numbers to numbers, x's to x's. 4 times 3, so that's going to be 12, and then x squared times x squared is x to the 4th. This is 12x to the 4th. 4x squared times 2x, that'll be 8x to the 3rd. 4x squared times negative 1, so just negative 4, and then x squared. 3x times 3x squared, so 9x to the 3rd power. 3x times 2x, that'll make 6x squared. And then negative 3x. 2 times 3x squared, so this will be 6x squared. Two times 2x, so that'll be 4x. And then 2 times negative 1, negative 2. Now let's color in some like terms. I've got this is an x to the 3rd, and this is an x to the 3rd. There we go. And what else we have? We have a bunch of x squared, so let's do those. Got this is an x squared. The center one is an x squared. And I've got two terms that both have just an x, so negative 3x and 4x. All right, now I'm ready. Let's combine some like terms. I've got 12x to the 4th, 8x to the 3rd, and 9x to the 3rd will make 17x to the 3rd. Negative 4x squared plus 6x squared plus another 6x squared. So this will make 12, and then I can subtract 4, so that'll be 8. So plus 8x squared. 4x and negative 3x will make positive 1x. And then minus 2 at the end. Okay, so my answer there is 12x to the 4th plus 17x to the 3rd plus 8x squared plus x minus 2. All right, last thing I want to do is let's do a real world model, just like we did for addition and subtraction. This one says a biologist has found that the number of branches on a certain rare tree can be modeled by the polynomial b of x, b for branches, equals 4x squared plus x, where x is the number of years after the tree reaches a height of 6 feet. Okay, then the number of leaves on each branch can be modeled by the function L of x, L for leaves, equals 2x to the 3rd plus 3x squared plus x. Write a polynomial describing the total number of leaves on the tree. So if I can figure out how many branches there are, and when I've got a function for that, and I've got a function for the number of leaves per branch, then I can take the number of branches, multiply that by the number of leaves per branch, and this will give me the total number of leaves. So that's my plan. I'm going to multiply these two together. Let's set up a box. So this will be 2 terms by 3 terms. Here I've got 4x squared and then plus x. And along the top, I'll do my leaves function. I've got 2x to the 3rd plus 3x squared plus x. And let's do some multiplication. 4 times 2 is going to make 8. And then x squared times x to the third is going to be x to the fifth. So this will be 8x to the fifth. 4x squared times 3x squared. So 4 times 3 will make 12. X squared times x squared, that'll be x to the fourth. Four x squared times x, so it'll be 4x to the third. X times 2x to the third, so 2x to the fourth. Three x squared and this x will make 3x to the third. And lastly, x times x, this is x squared. All right, we're going to combine some like terms, but first I've got x to the fourth here, x to the fourth here. I'm just going to color these cells the same. And I've also got 2 of these with x to the third, so let's make those a different color. Okay, the total number of leaves on this tree, let's call this t for total. T of x is equal to 8x to the fifth. I've got 2 terms for x to the fourth, so let's combine those. 12x to the fourth plus 2x to the fourth, that's going to make 14x to the fourth. 4x to the third plus 3x to the third, that's going to make 7x to the third. And plus x squared. So my function for the total number of leaves on this tree is 8x to the fifth plus 14x to the fourth plus 7x to the third plus x squared. So hopefully that helps you out with adding, subtracting, and multiplying polynomials.